Finally, we will develop an algorithm that computes the least solution that satisfies the constraints. So let us recall the factorial program and the least solution that we are looking for. The idea is to compute an analysis assignment that solves the constraints obtained from the program graph. The constraints are shown here, where for the initial node we incorporate the single abstract memory where x is positive and y is 0. Chaotic iteration is the simplest possible algorithm we can imagine. In the initialization step, the analysis information for all nodes except the initial node is set to the empty set. For the initial node, we set it to be the set of initial abstract memories. We then perform iteration steps as long as one of the constraints obtained from the program graph is not satisfied. This means that there is an edge where the result of applying the analysis function to the analysis information for the source is not contained in the analysis information for the target. In this case, we update the analysis information at the target to contain also what was missing. Under our assumptions, this algorithm always terminates and it constructs an analysis assignment that solves all the constraints. It is time for you to perform this non-deterministic chaotic iteration algorithm for a simple abstract memory where x is positive and y is 0. You should obtain the result displayed before. The online system implements a deterministic version of the chaotic iteration algorithm. It does so by using a work list. The initialization step is as before, except that we also initialize a work list W to contain just the initial node. Iteration is then performed as long as the work list is not empty. We choose a node from the work list and remove it while doing so. Then we look at all the outgoing edges from that node. If the corresponding constraint is not satisfied, we update the information at the target of the edge and place the target node on the work list. The work list can be organized in many ways, in particular as a queue, where nodes are taken from the front of the queue and nodes are inserted at the rear. You should now read the text in the book, doing the try it out on the way.